Blockchain layers are categorized into 4 categories: Layer 0 to Layer 3. Blockchain, sometimes referred to as distributed ledger technology, makes the history of any digital asset unalterable and transparent through the use of a decentralized network and cryptographic hashing. Layer 0 blockchains can be referred to as a network framework that operates beneath the blockchain. It is the very first layer among all blockchain protocols. The 2 most prominent Layer 0's blockchain protocols are Cosmos and Polkadot. Layer 0's are linked with all other protocols to create interconnected value chains, providing a more upgraded and credible option compared to smart contracts. Through cross-chain interoperability, Layer 1's can communicate with each other, allowing for trust-free interchain transactability and pooled security. By allowing for the creation of customized blockchains, Layer 0's let developers build blockchain protocols to their exact specifications. Developers can decide whether the blockchain has staking, on-chain, or off-chain governance, communication with other blockchains, and slashings. They can choose whether they want more security by trading off some decentralization, or more scalability by trading off some security and decentralization. The trade-off between scalability, security, and decentralization is called the blockchain scalability trilemma. The blockchain scalability trilemma is relatively simple to understand. When a network's pillar is improved, the other 2 pillars suffer. If a network's scalability gets improved, it becomes less secure and less decentralized. If security receives the best treatment, the network will be significantly less scalable and have a lower level of decentralization. Scalability refers to how well a system can manage increasing amounts of data. Blockchain scalability is how well it can handle an increasing number of transactions. The major part of the issue comes from the fact that the blockchain requires all participants to agree on the validity of transactions. Bitcoin has a transaction per second rate of 7 transactions per second. Ethereum is sitting at a slightly higher spot, with roughly 30 transactions per second. These figures don't seem so bad at first glance, but Visa's throughput can be upwards of 1,700 transactions per second. The blockchain is inherently secure, but is not entirely immune to hacking. If a hacker is able to secure control of more than half of the network, 51%, they are able to alter a blockchain and manipulate transactions to steal from the network. In blockchain, the more nodes, the more security. Decentralization talks about how control is shifted from one central entity, company, or government, and is split across smaller groups to govern something. In blockchain, decentralization gives power to people across the world to govern using their computer, i.e., nodes, rather than having a central control of the network live with one person or party. The Layer 1 blockchain is a collection of solutions that improves the Layer 0 blockchain. It has its own consensus mechanisms. Blockchains in this layer have limitations such as scaling. Developers have to make compromises when designing the applications, and when there is an issue in the Layer 0 protocol, it will also affect Layer 1 as well. Bitcoin, Ethereum, Cardano, and Binance Coin are some examples of L1 blockchains. The L1 network is in charge of transaction settling. For the majority of networks, this entails accounting for a user's account or wallet using asymmetric key pairs and the related cryptocurrency or token balances. Every L1 network has a native token that allows users to access the network's resources. You pay for network services like transmitting, minting a token, or invoking a smart contract using a network's native token. It should be noted that not all Layer 1 networks provide the same set of services, despite the fact that they all offer transactions. When comparing Layer 1 networks, it is critical to understand their consensus method as well as the benefits and drawbacks they provide. Some improvements cannot be made to Layer 1. Technological constraints limit the available remedies. Also, certain changes are difficult, or almost impossible to do on the main blockchain network. Ethereum, for example, upgraded to proof of stake, but this process took several years to develop. Layer 2 refers to a set of off-chain solutions, or separate blockchains built on top of Layer 1s, that reduce bottlenecks with scaling and data. Layer 2s extends help to offload the heavy burden of transactions from the mainnet through smart contracts that integrate and benefit from Ethereum's robust decentralized security model. In summary, Layer 1 handles security, data availability, and decentralization, while Layer 2s handle scaling, related to transactions. Two major examples of Layer 2 solutions are the Bitcoin Lightning Network and the Ethereum Plasma. Despite having their own working mechanisms and particularities, both solutions are striving to provide increased throughput to blockchain systems. Layer 2 is for scaling. Layer 3 is for interoperability. They enable communication, connection, and interaction between various networks and environments. The benefits of Layer 3 solutions emphasize routing value signals across numerous DLT systems and measuring value in packets. In light of this, Layer 3 protocols can provide efficient communication between Layer 1 and Layer 2 chains and the related apps and services included there. Examples of Layer 3 connectivity is the Cosmos blockchain. The Tendermint core serves as the Layer 1 protocol, while the Cosmos SDK facilitates Layer 2 protocol functionalities. The IBC protocol can help any application with reliable and safe inter-module communication. On top of it, you can also identify the benefits of multi-chain smart contracts, alongside cross-chain asset transfers, with the IBC protocol. As one of the top Layer 3 protocols, IBC facilitates a reliable and secure module for interconnectivity among blockchain networks. It supports various tasks, including data transfer, authentication, and ordering throughout multiple blockchain networks. So, in summary, Layer 1 is the first layer that is instrumental for supporting decentralized systems. Layer 2 protocols mitigate the scalability shortcomings of the underlying blockchain. Unfortunately, most Layer 3 protocols, decentralized applications are today running directly on Layer 1 protocols, skipping Layer 2. It's no surprise that these systems are not running as smoothly as we would want them to. Layer 3 applications ultimately create real-world use cases for blockchains, so they are definitely important. However, in contrast to legacy networks, they won't capture nearly as much value as their base blockchain. Thank you for watching.